Hello everyone. Today let's solve the problem number 297. Serialize and deserialize a binary tree. So you can just go through the question and you can just try to understand with the help of example that they have given. So let me summarize the question for you so that it will be easier to understand. So what the question states here, um, we need to design an algorithm to serialize and deserialize. Means serialize means we have to convert a binary tree into the string here. So you can just take the example here. We have to convert the binary tree into the string. That's what serialize means. And what does deserialize mean then? We are converting the string back into the binary tree. That's what the deserialize mean, right? So we need to design an algorithm to serialize and deserialize. So the structure of this tree, the structure of the tree must be preserved during this process. So they are asking us to preserve the structure of the tree during this process. Means the structure must be same in this case. So what we need to design then? We have to design the algorithm to serialize and deserialize. So serialize means, again I'm telling, convert a binary tree into the string. Deserialize means we have to convert the string back into the binary tree. I hope you know what serialize and the deserialize mean. And one more thing we have to keep in mind, that is we have to preserve the structure of the tree during the process. So I hope the question is completely clear. You can clearly see we have the input here 1 2 3. We don't have any nodes here, so we are considering null twice, and finally 4 and 5. So the output has to be same here. Same goes with the second example as well. We are having no elements, so the output has to be empty array in this case. So I hope these examples are clear. Here also they have mentioned the same thing. Here serialize, they have given encodes a tree into the single string. Nothing but we are converting a binary tree into a string. So the return value has to be string here. This one we have to keep in mind. Just keep in mind here the return value has to be string here. They have strictly mentioned. So here for the deserialize, they have given decodes here encoded data to a tree, to the tree. Nothing but we are converting the string back into binary tree in this case. And the return value here is tree node they have given. Strictly they have given here return value is tree node. In this case here the return value is string for the serialize. I hope the question is completely clear. Now initially let's start with the approach followed by edge cases one by one, and then write the code, and finally discuss the complexities of the code that we have written. First thing, let's go with the approach. So let's discuss the approach step by step. The approach that we are going here is with the pre-order traversal. I'll just give here pre-order traversal. The approach that we'll be making use of here is pre-order traversal. I hope this is clear. And the pre-order traversal follows the order. The order of the pre-order traversal is nothing but it follows the order root followed by left followed by right. Right. First we'll be considering root, then followed by left and right. We have already discussed about the post order as well as the in order, right? We know we should now we should be knowing about the order in which the nodes we traverse in pre-order, post-order as well as the in-order, these three things. So for this problem we'll be making use of the pre-order traversal. The approach that we'll be going with here is pre-order traversal. So the order of the execution of nodes will be root, left and right. This we have to keep in mind. First step is we are traversing the tree in pre-order. I'll just give you a pre-order traversal. Root, left, right. We know that one. And store the, why we are making use of this one? To store the values in the string. So this is the first step. So that is the reason we'll be making use of the pre-order traversal, just to store the values in the string. And next let's move on with the second step. So the second step, what we'll do, if a node is null, we will be storing n. This is important. Just keep this one in mind. If node is null, means if we don't have node, we'll be saving it as null, right? So if node is null, we store n. We'll be storing n to preserve the structure. In the question, they have asked us here one thing. While explaining, I said the same thing. We have to preserve the structure of the tree during the process. So during the serialization and deserialization, we have to preserve the structure of the tree, right? During the process. That's what they have given in the question. So here, in this case, so we'll be storing it as n if the node is null. So then let's move on with the final step or the third step, right? So to deserialize, so we saw how to serialize. One second. Yeah. To deserialize, what we'll do, we'll make use of the same pre-order traversal that we used in this one. That's similar to the serialize, right? What we did, we'll be making use of the same pre-order traversal, reconstructing the nodes in same order. We'll be making use of the same pre-order traversal to reconstructing nodes in same order. Reconstructing nodes in same order. So the output has to be always equivalent to the input, right? So here in this case, what we have done approach, so we are traversing the tree in the pre-order. Nothing but we know this is the order of the execution of the nodes for the tree, for the pre-order. Root followed by left followed by right, and we will be storing the values in the string. So the second step is, if a node is null, we are storing n to preserve the structure. So in the question they have mentioned, we have to preserve the structure of the tree during the process of serializing and deserializing. So if node is null, we are storing n here to preserve the structure. And finally, to deserialize, we use the same pre-order traversal, reconstructing the nodes in the same order. So I hope the approach is completely clear. This is the approach that we'll be going with, mainly pre-order traversal here. So let's discuss the edge cases step by step and then finally write the code. Then discuss the complexities of the code that we have written. Now let's discuss the edge cases one by one. So here the first edge case I'll be going with here is this one, empty tree. So let me give here empty tree. When I say empty tree, I'll just consider the input here, root equals this one. The tree has to be empty here, right? So the output will be empty here as well. So we don't have any elements, right, inside the tree. So the output will be empty itself. So let's consider, let's move on with the second edge case, nothing but single node tree. So when I say single node tree, we should be having only one element within the tree. So I'll just consider here input 1, root equals 1, only one element. So here the output will be 1 as well. So why the output is 1? We have only one node within the tree. So that itself will be the output. We are just serializing and deserializing, right? So in this case, the output will be 1. This is for the condition single node tree. Next, let's move on with the third edge case, nothing but only left child. Let me consider the input here. In this case, root equals 1 to null here. So here this will be tree looks in this way, right? Sorry, just give me a second here. This will be 1, 2 and this will be null. So here we are considering only for the left child, right? So we have the left child with the node value with the value 2, right, for the node, for that particular node. So the output will be here, the input will be 1 to null here, right? So the output will be same thing. Output will be same as input, right? So this is for the left child. Next, let's go with the another edge case, only right child. So we have previously we considered only for the left child. Now we'll be considering for the only right child. Here in this case, the input, let me consider 1, null, 2. So the tree will be in this way, 1 and 2, right? So the output will be same as the input, we know. The output will be 1, null, 2 for this one, right? So finally, we have to, let's discuss about the final edge case, nothing but full tree with missing nodes. Let me give here full tree with missing nodes here. One more line. So here, the input that I'm considering here is root. Let me consider 1, 2, 3, null 4, null 5. So this will be the input I'm considering. This will be 1, 2, 3, null we have, null 4, right? And null 5. So this is missing here. This is mixing and this is mixing here in this case. So this is for the condition full tree with the missing nodes. So the output has to be same thing, right? 1, 2, 3, same thing. Null 4, null 5. So these are the edge cases that we need to consider here. First edge case was for the empty tree. Second edge case was for the single node tree. Third edge case was for the only left child. Fourth edge case was for the only right child. The last and the final edge case that we discussed was for the full tree with missing nodes. I hope all the edge cases are clear. Now let's start writing the code. I'll just explain the code while writing the code itself and then finally discuss the complexities of the code that we have written. So let's start writing the code. So here let me clean up something. Just remember this one thing. The return value here is for the serialize is string and the return value for the deserialize is tree node. Just let me delete this one. This is fine. Just give me a second here. So yeah. Initially, within the serialize, we have to make use of the array to store the serialized values, right? So I'll just give here let result equals empty array. Let's initialize this one to the empty array. Let's make use of the ify. So ify means immediately invoked function expression. If you don't know what ify is, please just go through the JavaScript playlist. So I have explained that one with a very simple example, or have I considered 2 examples? So yeah, I have explained that one clearly. The method, the concept of if we immediately invoke function expression. So we'll be making use of that one. Syntax is within the parenthesis we need to start here. Let me make use of the function encode in this case. Encode, I'll just pass node here. This is fine. The next thing is we have to store the value or n for null. We have already discussed this one. So if node is null, then we are preserving n. Then we are making use of n because to preserve the tree structure. Or if the nodes are present, then we have to store the value of the node, right? So that's what we'll be doing in this case. I'll just give here result dot push of node. If node is present, we will go with the value of the node, else we'll be giving n, right? Just to preserve the tree structure. I hope this is clear. This step is clear. Next step is we are going with the recursive pre-order traversal. As we have discussed, we are making use of the pre-order traversal, right? So we are just making use of the recursive pre-order traversal. If node is present, then encode because we are making use of the recursive function here, encode, right? So this one recursive, we have to consider left and right subtree, right? So I'll just be going with left here. Let me copy the same thing here. Don't want to write this one again. So let me change this one, make the necessary changes here. So here this will be right instead of left. So this is it. We are just making use of the recursive pre-order traversal here. So one more thing we need to remember is whenever we are making use of the if, so we have to give parenthesis here, and in this case we are passing the root. So just remember this one. I forget this one many times whenever I make use of the this one, immediately invoked function expression. So I forget to give the parenthesis here most of the times. So just remember this one. Finally, we have to convert the array to the string. So we know that the return value is string, right? So serialize means we are converting the binary tree to the string itself. So the return value they have mentioned, it should be in the form of string. So let give here return result dot join. Just give comma here. This is fine. We are just converting array to the string here. This is fine. Let's move on with the deserialize function. So here we have to convert string back to the binary tree here, right? We have the parameter data. So first what we'll do, this is completely similar to the serialization itself. So initially what shall we do? Let's split the string into array just to track the index. So again I'm telling, just keep this in mind. We are splitting the string into array to track the index. So I can just write in this way. It values equals, we are splitting here. Let's make use of the split. This is fine. And to track the index, we'll be making use of index. We'll be initializing index to 0, right? So again, we need to return, right? So in this case, we are returning the tree node. So let's make use of the if again here. This goes for this one will be going with the decode function name decode, right? So first step within this function is if we have the node value null or n, right, and we have to move the index. So how can we write that one? If values of index, this one, if it is null, we are storing that one as n, right? So if it is n, so then what we will do, we will convert the value to the tree node. So how can we do that one? So I can just give here, so this one, if the value of the index, so this one, if the node is null, then what we have to do, we have to return null and move the index, right? So this one I completely forgot. Node value is n. Here in the serialize, if the node value is null, we are just preserving, we are just giving here n just to preserve the tree structure. We have to deserialize. We have to this one, convert the string back to the binary tree. In this case, we have to convert the n back to null, right? If node is not present. So if the value is n, then we have to return null and move the index. So that's what we have to do. Sorry. This one has to be, let's move the index as well as giving it null. I hope this is fine. Next, let's convert value to the tree node. So I'll just make use of the variable node here. This will be new tree node. Values we have considered, right? Within the array, let me increment the index. Let's move the index here. In this step, what we are doing, we are just converting value to the tree node back. So next step is let's recursively build the left and right subtree. So I'll just give here node dot left. We are just recursively building the left and right subtree. Just remember this one. Decode. Same goes for the right subtree as well. Let me copy this one and make the necessary changes. I'll just give here right. This is fine. The final step is we have to return the reconstructed node. Nothing but node in this case. Let's just return the node. This is it. And one more thing, we have to give here parenthesis. Don't forget this one as we are making use of if, right? I hope this is clear. Let me leave some space here so that it is easier to understand. So yeah, let me format this one once and let me run the code. So we are getting some error. Line number 9, return result.join. So result is not defined. What we have considered? RES. So yeah, let me make this one RES itself. Let's run the code again. So now you can clearly see the sample test cases are getting passed here. So let me hit the submit button. So you can clearly see all the test cases are getting passed here. So the code works absolutely correct in this case, right? So let's quickly discuss the time complexity and the space complexity of the code that we have written. So the approach that we went with here is pre-order traversal, that we know, that we have discussed completely. So what are the steps? What are all the steps that we did in the approach itself, right? In the beginning itself. So the approach that we went with here is pre-order traversal. So the time complexity would be here. Overall time complexity would be big O of n, because we are making use of the recursive stack as well. Here in this case we are visiting the node, each node exactly once. So the time complexity would be big O of n here. And what would be the space complexity here? Space complexity would be big O of n as well, right? I hope this is completely clear. The time complexity and the space complexity in this case would be big O of n, right? I hope the solution here is completely clear. For now, this is it. Thanks for watching, guys.